So, welcome back to our chemistry flipped classroom. And today we are talking about valence electrons. So, our goals for today are going to be to define what we mean by the term valence electron and to be able to draw Bohr models representing all the electrons and specifically the valence electrons in an atom. And then to be able to use that information in order to predict what charge of ion an element is going to form. So let's begin by defining valence electrons. So valence electrons are those electrons that are in the highest occupied energy level of the atom. So we've been talking about the structure of the atom, and we know in the center we have the nucleus, and then in the different energy levels or orbitals that we have electrons. And so those electrons that are in the highest energy level, they're in the outermost shell. Those are the ones we're talking about as valence electrons. And these are important to us because these are the electrons that are generally involved in the formation of bonds, whether we're forming covalent bonds by sharing electrons or whether we're forming ionic bonds by giving and taking electrons. It is these valence electrons that form the bonds. So, as usual, we're going to turn to the periodic table to learn something about the elements. And so if we look at our periodic table and we're looking at those main group elements, these ones in group 1 and 2, the alkali metals and the alkaline earth metals, and then these in 3 through 8 or 13 through 18 that are the boron family, carbon family, nitrogen family, oxygen family, halogens, and then the noble gases. And so just by looking at where they are on the periodic table, we can know how many valence electrons these main group elements have. And so you can see that group 1 has 1 valence electron, the alkali metals and hydrogen. Group 2, the alkaline earth metals, have 2 valence electrons. Moving over to the boron family, we have 3 valence electrons. The carbon family has 4 valence electrons. Nitrogen family has 5 valence electrons. The oxygen family has 6. The halogens have 7. And then, of course, the noble gases, with the exception of helium, have 8. Helium has only 2, but that's still a full outer shell because helium's outer shell can only hold 2. So just by looking at where they are on the periodic table, we can determine how many valence electrons the element is going to have. So when we look at atomic structure, and we're going to look at a Bohr model here, remember the Bohr model says that the electrons are in orbits orbiting the nucleus. Today, our modern understanding is that they are in shells that have a specific energy distance, but we can still use the Bohr model as kind of a shortcut. So when we look at this Bohr model, we see all these protons and neutrons here in the center in the nucleus. And then in the first energy level, we see two electrons. These are not valence electrons. These are core electrons. In the second energy level, we see 8. So that's a full energy level. And in the third and outermost energy level, we can see that sodium has only 1 valence electron. So there is only 1 valence electron in sodium. So we can, again, go back to the periodic table to determine number of valence electrons. So now it's your turn to try, and I want you guys to tell me how many valence electrons are in each of the following atoms. So I'm asking you to determine number of valence electrons in helium, oxygen, sodium, and chlorine. So I'm going to have you pause the video now and write down how many valence electrons are in each of those following atoms, then unpause and come back and check. So helium has 2 valence electrons. Oxygen has 6 valence electrons. Sodium has only 1 valence electron. That's the example we used just a minute ago. And chlorine has 7 valence electrons. So now we know how to use the periodic table to determine how many valence electrons there are. Let's talk about one of the other ways that they are important. So we said that they are important because these are the electrons that are involved in bonding. Because they are the ones in the outermost energy level, they're also the ones involved in the formation of ions, either in terms of losing electrons or gaining electrons. And atoms are going to either gain or lose electrons in order to have 8 valence electrons. So if we go back to our periodic table that shows us the number of valence electrons, we can see that we want to either gain or lose electrons to get to 8. And so it's easy to understand over here where we have 5 and 6 and 7 electrons that we would gain 1 if we have 7 to get to 8. We would gain 2 if we have 6 to get to 8, and we would gain 3 if we have 5 to get to 8. But what's happening over here where we have 1 and 2 and 3 electrons? Well, let's look at our example of sodium again. So if we look at sodium, we can see that although there's only 1 valence electron, if sodium were to lose this 1 valence electron, this outermost energy level wouldn't be occupied at all. And so the outermost energy level would be this one, which has 8 valence electrons. So by losing 1 electron, sodium actually has a full outer level. So these ones that have 1 and 2 and 3 valence electrons are going to lose electrons. And so they're going to form ions with charges of +1 for the group 1s, +2 for the group 2s, and +3 for the group 3s. Group 4 really doesn't form ions very often, so we're not going to worry too much about its charges. But groups 5, 6, and 7, now they gain electrons, which is going to give them a negative charge. So group 5, or the nitrogen family, gains 3 electrons. It has a -3 charge. Group 6, or the oxygen family, gains 2, so it's going to have a -2 charge. And the halogens are going to gain 1, so they're going to have a -1 charge. So we have this all broken down here in this little table: +1, +2, +3. And then on the other side of carbon, we have -3, -2, and -1. So I hope that's helpful. As always, if you have any questions, please let me know, and I look forward to seeing you in class.